Hello.
Yes, we are live. We have a full house, I guess,
Yeah.
and red with a beard.
Now that I finally showed up for a night, I can shave. I think that's what I was waiting for.
Okay, we have lots to discuss, but I don't know where to start. Maybe if we want to discuss Eric's problem first with the old firmware, and then I can show what I have for the discovery layer, and then yeah, something
I
else.
there's some things that bothers me a bit more. You were talking about running out of tokens.
Yeah, so basically, I spend like extra $10 a month to finish what I have in plans. But I could go on far further than uh, what I have right now. But basically, I don't know if it's useful because you have to think first, right, where we are going and if it's even useful. Just because we can build it doesn't mean we have to build it. So basically, like when I build something and then I run out of if I hit the rate limits, then basically I stop and think what's been built and if it's even useful. I think like those breaks are a little good right now. But yeah, I have done quite a bit right now, so I don't know if everyone understands what I have. So I posted the architecture I have currently with all the discovery and agent uh, registration for the 8004, and there are like a couple of more things. There's some protocol released. I think like it's called 8128, which allows you to make HTTP calls signed with Ethereum private keys. So I had done this X402 payments in December during Christmas, but during that time I had found that you couldn't identify because it wouldn't send you the identity with the HTTP calls. But somebody has made a protocol or like a proposal, EIP proposal, that you could send the identity. So basically all these parts are composable. So I've done basically 8004 registry for the robot, and then X402 payments, uh, it, then also the wallets for the robot. The only thing is now right now left is the 8128 integration. So that's a lot of stuff. But do we want to start with that, or do we want to start with what Eric is trying to do?
No, I was interested specifically in the cyborg relationship between you and the computer. Exactly what you said. You said I've run out of tokens, but it's actually good because then I can pause and think about it, and that you could have gotten much further. No, I mean it's very interesting to hear it. How this relationship works, because in our ideal world, that's how working with a robot would be. Okay, we talk about the robots, being on a different planet doing what we tell them to do,
Yeah.
but you have a very different relationship with a non-physical AI. I thought that was
It
very
kind of extends my context, right? So when you're working with a large code base, uh, like you generally don't understand the whole code base, and there are like multiple people understanding it, right? So you are basically, when you don't understand one part of the code base, you are generally going to a colleague to understand how those things are done or whatever. But like when I'm doing it all these things myself, what I do is basically like have a agent uh, extend my thinking. So it's basically kind of a mental exoskeleton. You could think of it like that.
mm,
So the I've been making fun of everybody that I see doing this. It's a lot of fun, but I think the serious question for me is right now budgets and token limits in the plan are acting as the forced breaks when you stop and reflect and rethink your architecture or whatever. It seems to me the more natural way is like ideally you should be stopping and pausing and thinking at important decision forks. Is this a dead end? Should I back out? That kind of thing. But if it's turning out that that's only happening when you hit a budget limit, that might not be the best place to stop and reconsider, right? So I'm wondering if there's a good workflow for using Claude Code where somehow, like, all right, you give it a prompt, it does a lot of things very fast, but maybe you put in checkpoints that say if this condition is met, then pause and let's reflect for a while and reconsider the architecture. So I don't know, more deliberately designed orientation breaks as opposed to relying on like budget limits. Because the reason I think I'm a little wary of that approach is you happen to be a individual single guy with your personal budget, but imagine a big company with like people with like lots of spending authority. You can see somebody going like hypomanic and spending $1 million deep down a rut before like budget stops them. So what's the actual way they should stop and rethink what they're doing? Like, assume you had a spending privileges of $1 million worth of tokens. What would you do differently?
Basically, I would do something I learned about is like what was it? Somebody had ported SimCity from 1989 from C to a completely TypeScript based, so that it can run in the browser. So it's what was it called? There's some specific form of testing, a product based testing or something. So they basically write the ask the agent to test against the new code against the old uh, in a specific way. So that way you could stop or like or like guardrail against what the agent is trying to generate. So basically it's like, and like right now what I'm doing is a little bit exhausting because I'm always in the loop. So like I'm trying to keep all the context as the agents are doing all this stuff, right? So I'm basically like the guardrail of where it's, so I'm basically, it's like uh, riding a horse chariot, and then you're basically or like or maybe horse chariot is a little slower, but maybe driving a car or something, but you still have to steer a bit. So I'm still in the loop. So and it gets exhausting after a while. But I think there are people have discovered ways in which you could have like write the specification first. So the guy who ported that SimCity basically went to sleep, and then after 4 5 hours or 8 hours, the entire behavior was replicated in the TypeScript version. So and then he had written some like specific kinds of tests. So whenever the new code new parts of the code would be ported, that agent would test the new code against those test specification. That is how you kind of let a little more uh, agent run a little bit more with less control, and then you are not that is how I would do it. But I'm not still said that I'm still learning how to do it.
I think I was actually asking the reverse question. You are like talking about how you would take yourself out of the loop and let it run autonomously for much longer. I think I'm asking how would you inject the brakes at the right point so that it doesn't spend $1 million overnight on a task that should have cost like $100, right? So this is a budget management question. Like, how do you put in like the right control point? So I think something like test-driven development is probably the answer. Um, but not quite test driven development. It's not like, these are the tests that you must pass to be SimCity. It's more like these are the tests you must pass to assure yourself that you're still building the right architecture. And if one of these fails, you should stop and like, send an alert to the human who will then check and say, all right, maybe we should not use this database, we should use this other database or something, right? Like somehow I'm thinking, what's the right way to engineer decision forks? But anyway, uh,
The
I think
most
we'll discuss more about this, but I'm curious to see that architecture diagram you uh, posted because the way you described what you did, it feels yeah, I'm not able to build a big picture of what's going on there.
Okay, let me share the screen.
Rhett, were you wearing glasses before?
rarely.
Okay, yeah, because I don't remember seeing you in glasses.
I don't generally ever wear them on the computer because I don't really need them. But Sometimes I get used to wearing them. It's quite a lifestyle change.
Yeah.
Oh boy.
So a lot of stuff. Like, so I think I wrote like maybe 500,000 lines of code since Christmas, on weekends plus evenings
Ooh.
plus on Christmas.
Wow. Wow.
And like a lot of it has been discarded, but and the productive part maybe like 150,000 lines of code, 200,000 lines of code. And this is like maybe if I do full, if I had done it completely, I don't know if I would have finished in even in 2 years. And this I've done it in like 20 days.
Yeah, I think I read estimates somewhere at some point that human programmers, depending on the level at which they work, their productivity is between 300 to 3,000 lines of code per month. So this is like a couple of orders of magnitude higher. I think 300 is on the embedded end of the scale, and 3,000 is more like high level application layers of code. But
Yeah.
million is obviously like 3 orders of magnitude more.
And imagine if
Yeah.
you had more tokens.
But okay, yeah. So it's hard to see. Okay, yeah, I
I
can
can.
expand. Yeah, can you walk through the diagram, like what's going on?
Okay. So in December, what I did was uh, this is not scrollable, right? Let me open the original. It's better to open the original Excalibur. And this also is made via Claude Code, by the way. Yesterday, I think uh, Anthropic and Excalibur released some MCP server, so now you can connect. Now you can connect Excalibur inside Claude Code, and basically, like you could uh, like give a repo, and then it will draw the architecture diagram for you.
Okay. So million lines, and it's even drawing the architecture diagrams for you. So your situation awareness for this code base must be more like a middle manager level rather than hands-on level, right?
Except the embedded part, I would say something like that. So it's half a
Oh,
million, not a million.
half a million. Okay.
Yeah. So I think like I don't know much about the front end part, the React part much, but I do know a lot about the embedded part. It was just easier to grok what it's doing, and I'll like uh, the Python part. I would say it's like a little bit. I know what it's doing, but not completely. I'm more native to Python, so but like the React part, basically like I don't know anything what's going underneath. I'm just whatever the problems, I paste it in the like the agent itself, and the agent itself debugs whatever is happening. So let's go through what's actually this is about. So in December, I did this part, the front end and the X402 payment. So initially, what I did was make a just a front end to control it locally, so that this React web app would connect directly with this HTTP proxy to this motor controls. So this is the let's say architecture of the embedded part that's going on. So it has like the MDNS and the robot HTTP calls. And this self balancer part is not yet done, but basically, like when this calls, it controls the motors forward, backward, left, and right, and the sensor temperature, humidity part. So basically, like the first thing I did was have a React front end to locally control this robot layer, and then like I wanted to add wallets for each robot, and I didn't want to manage the private keys myself on the local computer. So I used something called Privy. It's acquired by Stripe right now, so it's wallet as a service. So basically, all the private keys are managed on the cloud, and you just are having API endpoints to manage wallets. So on the free tier, they have like 500 wallets or 500 users, so it's enough for our use. And I think Coinbase also has come up with something similar. So it's infrastructure for wallet management. And
I
then I
just heard
use
that Stripe also came up with 402 support
yeah.
like this week.
So and then once I had the wallet, so basically what I did was have a backend in Python, then it connects to the front end, which is done in React, and then the Fast API backend uses the Coinbase X402 SDK to make X402 payments, and this is basically like the middleware from Coinbase manages this X402 payment, and facilitator is something that Coinbase or anybody could run that verifies the payment and notifies the middleware if the payment has been done or not. So basically, this is all Coinbase part. And then I added some session management and uh, database for managing all the robots. So basically, if, when a robot has registered itself, you could it starts a timer, and then depending on the so initially I had kept like 5 minutes. So every one USDC payment would give you 5 minutes, and this all would be managed with SQLite and portable to Postgres if you want to manage and if it scales or something. And
All this is running on the DigitalOcean server.
yeah, it's running on it, but I think I'll soon shut it down and move it to Hertzner because DigitalOcean it's like I was getting like one CPU for $8 or something, and then I couldn't compile the backend or the front end React project on that one CPU. It would run out of RAM. And in $15 on Hertzner, I get like something like 8 GB CPU, 8 GB RAM, and then four CPUs. So like I can do the entire thing on Hertzner. So I am planning to move it slowly to Hertzner. Not shut it down, but like it's in the process. And this is running basically on yakrover.com right now.
Can you explain real easily what is the complexity in running a wallet and why you need a wallet service?
You could basically what I have done for this repo. So it's quite easy to do. It's then about the security. It's not actually about like how much I like the complexity of it. It's just that I didn't want to manage the private key on the server. So what they do is they have, at least they claim that it's run in some trusted execution environment, and then they provide some security. So like Coinbase also provides something similar with their wallet SDK. So it's called what is it? Server. It's called server wallets in Coinbase SDK. So basically, they manage the private key. So then you don't have to worry about managing private keys in your server and the security aspects of it. So in this part, which the 8004 registry, what I did was used web3.py, which is maintained by Ethereum Foundation, to generate the wallets locally. But then like I was storing it in an environment variable. For that experiment, I didn't care because like I was just experimenting with the 8004 registry, and then like it's just a throwaway wallet right now. But you could port this part, what I've done for 8004, also to Privy or any wallet management service.
So the service still has to have like an API key, like just some sort of credential, but you can like
Yeah.
have a
Yes.
different secure. I guess you can have different permissions depending
Yeah.
on.
So it's like a different security model, I would say.
Yeah. Okay.
If you used Privy for the 8004 discovery part, what would happen? The wallet would go to the Privy part, but 8004 you would still run
Yeah.
some
So
service on your DigitalOcean.
yeah, so basically, like what I have is like it's a very crude implementation right now. So I have different scripts. What it does is, so there I have a script called generate wallet. So it will generate the wallet and store it, and then I have like another script for register tumbler. So it will register the tumbler to the on chain, and then like I have another script called discover tumbler. So what it will do, it will scan the Ethereum blockchain and then give you the agent. So it's what it does is basically when you register, it mints an NFT and then stores the uh, JSON file on IPFS. And when you scan the blockchain, you get the URI of the IPFS. And from that IPFS, what you do is like you find the MCP server, which I am running here. And with that MCP, and that MCP server can be loaded into any uh, like LLM capable client. And then so I'll come to this. Yeah. So basically, I also made after this 8004 registration. What I did was like make a MCP server for the Tumblr. So this Tumblr is basically it has like 4 HTTP endpoints, and then I made a MCP server with fast MCP that would call this HTTP endpoints. So what you can when you and then I also use the ngrok SDK to expose it to the outside world. So basically, once you have the MCP server URI, which is stored on the IPFS, like any LLM in the world could load that MCP server and then talk to Tumblr to move it forward, backward, left, and right. And that discovery of the MCP URI is done via 8004 registry.
Okay, so let me make sure I understand the what it would look like from the perspective of somebody who's has a robot but is trying to register in the system. This
Yeah.
person would go to yakrover.com, fill out a form with some details that would create an 8004 record and also a wallet for that robot that you currently are storing on the server, but in future will be a privy wallet. And then it would expose the controls that other people can discover via 8004, and then the server will allow some teleoperation by customers paying money to the server, which then goes to the robot's wallet, right?
Yeah, so that is the ideal flow we would want. But right now, all this is like in separate repos. So basically, the 8004 registry is like a command line thing. I do it myself. And then you can actually go and find uh, the Tumblr on the testnet actually. If you go to the testnet, if you so and then you also can specify the kind of agent you are registering. So I made a new category called robot. So everything that basically registers to the blockchain, if can like have this category, and then basically you could filter. You could have a website that basically scans the blockchain and filters and lists all the robots. And then if you go to the metadata, uh, you get this. This is like the my public URI or the ngrok random URI it has given me. So this could be. So I also have a script called update. So if somebody is changing the URI of the MCP server, they could just run the update script, and then it would update the JSON on the IPFS. So that way you have like a updatable location or URI. So this is what is stored on the IPFS.
So
And
on chain, there's just a pointer to where on IPFS the
yes,
document is, and then the
yes.
document can be changed whenever it wants.
Yeah. So this is like the registration is one time, and then like the endpoint is like changeable and it's on IPFS. You could always update the IPFS thing. So this is like all like a little shaky, and then like these are the MCP tools I have exposed. So it can always check is the robot online, and then get temperature, humidity, and then move has like 4 parameters: forward, backward, left, right. And yeah, so this is the registry, and then like it's the agent card. It's not online, so I cannot, but it has like a, yeah, I also added some extra metadata like a fleet provider and the fleet location. So fleet provider right now I just kept it as yakrover.com/Finland. So basically like you could, somebody could query if yakrover.com has some robot fleets in Finland or not. So that is some extra things I have added, but that could be changed anytime we want. So this is like the 8004 registry part. And like for IPFS, I used a service called Pinata. It's like a common, many people use it. You could use it, change it directly with IPFS, some other service too. And yeah, so fast MCP is like I think it's also in the official Anthropic agent SDK. So that is how you are basically like creating, exposing Python based endpoints or tools and creating MCP servers. And then ngrok also has a Python SDK, which basically exposes your own ngrok URI to the outside world. And then basically I was able to load this MCP server into my Cloud Code, and then I have it like I could talk to Cloud Code anywhere on my phone, and then it would just move the tumbler around. It was fun. You could just talk to it.
Does it get images?
Not yet. That
Okay.
endpoint I have not exposed it yet. So only that, if you can see it here, right? These are the things I've exposed. So I could add one more
Okay.
endpoint and then expose it via MCP and to get a picture. What else is there? I think like this is most of it. Yeah. Yeah, but this is like this still needs some integration. So all these green parts could be integrated into this blue part. Then we have like a single service that could run on yakrover.com and Hertzner, and then like do some front end beautification to do it properly. And the robot part, I also made last week. I updated this one. The front end part that is in a separate repo, I updated it so that uh, it could update the Kalman filter parameters and the PID parameters from the front end itself. So basically, like if you would adjust the KI parameters, then it would change it on the. So I've exposed the like the PID and Kalman filter parameters via HTTP endpoints, and then I call the setting parameters from the React front end, and then I could basically try to balance or set the parameters for balancing from the React front end. So that is some extra thing I did. It's not self-balancing yet, but yeah, that is also a part of the front end right now.
So most of it is not the robot.
No, yeah, but you could easily expand this for any robot. This is like the simplest
Yeah.
robot we. Yeah, so this is what I have right now.
Another question. It sounds like anything that's in the robot category on the blockchain, your discovery mechanism will find it and list it on yakrover.com as a robot. And whatever that person has declared as the capabilities of that robot on 8004, you've exposed it as HTTP endpoints and then also an MCP server, but 8004
Yeah.
doesn't have any such restrictions, right? So what happens if your scanner finds something called a robot and there's a blob of like some description of what it is? How does it parse what it is, what it can do, and list it? Like conceptually, what will happen then? Like, will it detect that it has an MCP server exposed? Will it detect that it has like a forward, backwards, left, right type low
Yeah, so
level
it's
control.
basically a JSON file, right? So you could have, so right now I have like an MCP server, but I could imagine like you could have more properties. So they have some guidelines on how to add these, but like I was just trying to get here as fast as possible. But you could imagine like a service named uh, some like let's say lifting 10 kilos or something. I don't know. Uh,
So what's the best way to think about like how to like basically connect to and operate this robot? Should you like basically give an LLM this JSON file and say, hey, figure out what this thing does, and then uh, connect the controls for teleoperation for me via yakrover.com? Like I'm thinking, even without knowing about our project, some researcher somewhere just adds a robot to the robot tag. Can I potentially like basically interrogate what he's put there, figure it out, and start controlling
yeah.
it if there's enough permissions?
So basically, like they need this discover like discover robots script I have written or something similar to that that would scan the blockchain for these agents and then filter it via robots. And then once they have the entry for the robot, they would get this JSON file, and from there they could parse whatever the services robot is providing. So that
But
scanning part,
only MCP is like a standard service that you like. What other kind of services could you possibly expose?
like I didn't even check that. Like this, maybe 8004 has some extra, like
Is this a eight? This is an 8004 like protocol.
yeah. This is like how they have suggested to write the JSON file.
Okay, I mean an
You see,
MCP server seems like maybe not the worst solution for this generally. If like
Yeah. So
robots
and like
always just
yeah,
exposed in MCP servers because that kind of offers that discovery
yeah. So basically, what you're doing
functionality.
is registering an agent, right, on behalf of Tumblr. So basically, like that is what is actually happening.
if you open the specification for the XTR 804, there are quite a few examples, like exposing just a plain web server or the A2A protocol and stuff like that.
Yeah, so there are lots of stuff, but this is like the fastest thing I could create. So this requires actually some more. Uh,
If you go down the page, there is a sample, maybe here, yes. See the list of services,
yeah, so this is the
MCP,
list of
A2A, web,
yeah,
email, even
yeah.
DNS.
Initially, I was thinking something called OASF. I don't know what it is, but yeah, Open Agent Schema Framework. So actually, Claude Code suggested to pick something from here, but I wanted the simplest thing possible. So I skipped this and just expose the MCP. So basically, like, yeah, you could imagine you have like a robot category, something here, and then skills, what it has, what the robot does, fly, roam around, or whatever.
Yeah, this is all super impressive. I'm just wondering how I can get on this train, basically.
So basically, like, you just point Cloud Code to the repos and asking questions, because like I myself don't understand the whole code base, so it's
But you have such a nice diagram.
that is also made by Claude.
Yeah.
The other important part is that only one piece of this runs on a robot.
Yes, yeah.
And so you don't really have to run all of it. So you have to
No.
register with it.
So yeah, so basically, like you could have a simulator, right? Instead of this robot, you could just have a simulator or a Python script that accepts these endpoints or and then gives out a JSON response, and then you could load that Python MCP fakes rover into this MCP and register it. So it's like you actually don't need even a actual real robot for this. You could just simulate the entire thing. And the 8004, like what they intend is like on-chain software agents, right? So it's intended for that, but we are just extending it to real robots. That's it. Yes. More questions about this? What I have done? The monster I created. I don't know.
Exactly. It's 500,000 lines of code. But you were,
Well, this is I. This is like 150,000 or something. The total what you are seeing here.
if you had to do it yourself by hand without computer help, how many lines of code would it be?
Well, it would be like 100,000 or something, but I wouldn't be doing it in like 20 days. It would be like 2 3 years uh, full time
By then, technology
job doing
would
all of
a
this.
few times.
Yeah.
So you could never keep up.
And yeah, so right now they have. I think yesterday someone released something called sign in with Ethereum. So basically, all these HTTP calls you see from the MCP
Hmm.
from this one could be added like with uh, identity, and the X402 could also be done. HTTP calls there could also be done with those. That is something I want to try out. And then yeah, the self balancer part, which I have to tune. So I've written basically like a, PID filter, or like Kalman filter was and PID control, but it's not balancing. It keeps on oscillating. So I had to find the parameters which would make it balance.
Did you try giving Claude Code that job?
I was just thinking about it. So like how it could get the feedback from the actual robot about the angles, and then try to adjust the parameters. So that was on my mind, but like I haven't implemented it because it's like I'm getting a little like this is constantly on my mind, right? Because I am also in the
Yep.
loop, and then it gets exhausting after a while, like because I'm constantly think, even if I'm like if I hit the rate limit, this is simmering in the back of my mind, like how to get there, and then so it's so I had to maybe, I don't know, take a break or something.
I know just what you mean. But
Can I
there's something
perhaps
wonderful about thinking you could just go to bed and you just hear this robot flopping around in a closet somewhere trying to tune itself.
can I ask a slightly different question? Can the robot ask Claude Code to write code for it? Okay, we keep on talking about machine learning. So I have a robot. I want to learn how to walk. So I flop around, and as I flop around, I learn what makes me walk. What about the other way? I'm a robot. I want to learn how to walk. I tell Claude Code to write me code that makes me walk. Is that even
Yeah,
doable?
like you're basically trying to close the loop, right? So you could register an agent on behalf of Tumblr that
Yeah.
talks to and then you just basically need a over the air firmware update. So you could have like a agent specified with some skills for embedded, and then the agent registered on behalf on Tumblr basically should be able to talk to the other agent, and then you need over-the-air firmware update for the ESP32.
Okay, so the only piece missing is how does a robot say what it wants?
I
Not
think that problem looks like it's already solved. The robot just calls the already exposed um, API from on the outside. It's just calling itself, but the mechanism is the same. I think the actual unsolved part is the one Anuraj pointed out, which is how does, while it's trying to like um, program the robot to self-balance or whatever, how does it find out whether the code is working or not? Because it's not pure software. So I think two answers to that is, one is you get telemetry from the IMU, which gives you some data on whether or not the balancing is working. And the other is maybe you have like a camera watching the robot as it flops around, and that gives you like, data to tune it properly. So, but the robot asking Claude to, basically train it to walk or whatever, that I think is already solved. We just have to call the loop from the
no,
robot itself.
I don't think you understood my question. My question wasn't on this level of how the communication goes, but how does a robot, it's a very small brained robot. What can these requests look like?
We can always update, right?
No,
So we
I'm the robot. I'm a,
well, if we are able to run the Raspberry Pi, we can always run a small language model on it.
no,
But
I
these
think I get your point, Mayor. It's more like, how does a baby even bootstrap itself into the learning loop with a bigger brained adult, right? So the baby's
okay.
first attempt is it just kicks around crying, and then the mom picks it up, right? So that's like first training iteration. Later, when it learns to speak a few words, it might, ask for food or want to be picked up or whatever. So it learns. So you have to bootstrap its own. I think what you want to do is have it have enough autonomy, even though it has a small brain, to reach the maximum its brain can do, starting from only being able to basically cry like a baby. So the first firmware version 0.01 that it has when it's first turned on should simply be something that's the equivalent of a baby crying. And from that, it should get to be, quote unquote, a fully educated adult rover having controlled its entire educational journey by itself. Am I understanding your question correctly now?
Yeah, except the baby brain is big, and the tumbler has an ESP32. I'm saying that
we
the
could
tumbler.
have something like a RPi learn, and then the ESP32 is just motor control.
No, just a second. I think my question is not clear. Let me explain. We have a tumbler. It has access to these 500,000 lines of code and 5 LLMs connected to it. Okay, so now how does the tumbler recognize the tumbler recognize that it needs new code, and how does it define what new code it needs? All the while, it's still a tumbler. Okay, it's not a Raspberry Pi. It's just ESP32 with whatever 8 mega. That's my question. Imagine you were an ant and you could say, gee, I need to know how to climb walls. And then magically you get a firmware update and now you know how to climb walls.
Is this like the Matrix where you call your operator and say, I need to know how to fly a helicopter?
Yeah,
I need
yeah, yeah. But unlike Neo is human. He's intelligent. The tumbler is not intelligent because we didn't give it much of a brain.
you can think of Tumblr like a hand or something, a hand or a leg, right? It's not a full. It's like it doesn't have the computation. It's like a hand of a octopus
Hmm.
or a leg of an octopus. It's not like the complete octopus. Unless we give it like the RPi, it doesn't have the computational capability to do what you are asking.
What I'm
So
wondering
tumbler
is,
is basically the minimum ESP32 to expose the affordances, and then something else is controlling basically. So this is like the motor control part at the lowest level.
I don't think that's entirely true though, because we've talked about before the ESP32 actually being the controlling computer. Even though it's a smaller brain, it turns the RPI on and off, right? And even though it has limited computation power, it has enough to have a lot of autonomous agency and to direct its own future. Like it can uh, run a self-balancing algorithm. It can run like an extremely simple policy of randomly wander and back away from obstacles. It can probably do a very simple version of slam. It probably can't do camera, but we have another camera for another ESP for the camera. So I think it has enough of a brain to be autonomous. And one way I would frame the question is, how does it discover the most it can do with what it has while remaining autonomous, as opposed to becoming an arm of an octopus or something completely controlled by something else? Yeah, because I think that makes it an interesting question. If you engineer these things to maximize their own autonomy bottom up, then the next level computer, the R5, will respect that autonomy and say, this is its own agent and it controls what it can do. And therefore, I can't just order it to do whatever, like jump off a cliff. I have to respect it, right? So bottom up autonomy, I think, is possible. It
oh
doesn't
wait,
have to be controlled.
you just gave a great example. The tumbler doesn't know that it was told to jump off a cliff. Okay, so I have a tumbler. I got instructions, and now I have two options. Option number one is I can ask my LLM friend, are these instructions dangerous? How do I carry them out? But the other option is a tumbler can ask its Claude code friend, please generate code for me so I'll know how to do what I was asked to do. Okay, so these two things are not the same. In one of them, somebody else is solving the problem for you, and in the other one, they're giving you the tools, the fishing rod, to do it yourself. So I'm wondering, what do these requests look like? Any ideas?
No.
Not currently.
Well, Anuraj, can the tumbler trust Claude Code to write a new firmware for it that will actually work?
So
Yeah,
I don't
I
have
think
ideas
that
for
is
how to solve this, but this reminds me of what Eric keeps bringing up, the subsumption architecture. Like the lower, simpler, but more to the ground exposed layer is always in control of the higher layer, and then it goes up. So control is lower, but capability is higher. So they go in opposite directions. Just thought I'd put that out there. But yeah.
So do you imply that learning is a higher functionality? And so should be in a different layer in that view?
Not necessarily higher, but it's more computationally demanding and more open loop and slower. And therefore, robot that's trying to do self-preservation, like not be ordered to run off a cliff, it has to look out for itself, right? How is it going to know that this order, which says, motor forward 10 steps, is actually going to take me off a cliff, and decide that, all right, third law of robotics kicks in, and therefore I should say no to the order, and then, do something else? That's asserting autonomy, which means it's telling the upper supervisory layer, this looks dangerous, give me a different order that I can follow without violating the third law of robotics. Something like that is what I'm getting at here. Because if the higher level is in charge, it will obviously have moral hazard, and that's what's all we're already seeing, that the drones in Ukraine, the first use is suicide drones. The supervisory layer will use it as like a tool, right? Which is not very interesting. But yeah, sorry, I interrupted. I think Anuraj was trying to say something as well.
So I think like the first thing we could try is like over-the-air update with a MCP endpoint. So basically, like the LLM should be able to generate code and upload it to the Tumblr. So that kind of uh, joins a part of the loop. But then after that, I don't know how it proceeds.
It may be a pure like AI art project or something, but having a tiny LLM
Mhm.
describe its feelings about how it's operating to the larger LLM in order to get an over-the-air update to fix it is kind of an interesting idea.
You think I'm depressed, and then it gets a new update and says, "Oh, sorry,
Yeah,
I'm even more depressed."
Yeah, like it
yeah, I
doesn't have
think
the capability to write a bunch of C code, but it can
actually like
interpret sensors.
there is a project I was trying. So like I think it was 2 years ago before I started on this blockchain stuff. So I was trying to run a small LLM on ESP32. Somebody has already done it. So we could take parts of it and then see. But then I moved on to this blockchain part and I couldn't continue on that track. But people have tried to run really small LLMs on the ESP32. It should be possible, maybe not very capable, but it should be able to generate some answers at least. And it's trained on specifically some specific stories. So you could the LLM on ESP32 would basically be trained on a small text set of text, and then it would answer based on those stories. So it was, I think, like nano stories or something. But I can dig that up if we want to try that out.
Nanostorm.
Uh, I have another question going the other way. So over-the-air firmware updates, basically, in the extreme case, it's like it'll completely rewrite what the ESP32 can do, right? What about the reverse question of, yes, I'm asking Claude Code to reprogram me to do certain new things, but I want to protect this core functionality that is completely protected from being overwritten. Can we engineer that somehow where it says, all right, you can over the air do flashing, but maybe the small fragment of code is fully protected and it encodes some like basic safety functions and things like that, and maybe that runs on a protected area? How would that work?
Yeah, so that is all solved problems. You can have partitions in the memories. So you basically, when you are uploading the firmware on the ESP32, you are also uploading the partition table. And when you're doing over the firmware update, it's basically like you keep the old firmware in one part and the new firmware in the like a certain part of the RAM, and then so you are, until the new firmware is flashed, you are always keeping the old firmware so that it's like not in a bricked state. So when you are doing over the firmware update, you are doing some partition table, and then you could also have another partition for like a completely unprogrammable part of the uh, memory. So basically, OTA doesn't touch that part of the memory, and then there should be a way to recover always. So basically, this is the project I was talking about. So you could run small LLMs on ESP32. Yeah, tiny stories, something. Yeah.
With over the
How
air,
much
can you?
memory?
Sorry.
How much memory do you need? And
I think the ESP32 we have should be able to run it. It has like 16 MB of like flash memory, so this is easily possible.
With over the air, what is the granularity of what you can update? Is it a file or is it at the byte level, or I don't know?
It's like, I think there is something called differential updates too. So basically, when the new firmware it compares with the old firmware, so only the differences are passed on. So that is also possible.
Ah,
So it's
cool.
like it's called, basically you don't want to send the whole firmware, you only send the differences.
Mhm.
So it's called differential update.
I think
So
this is going to be necessary, not a nice to have feature. I mean, if you look at Rhett's example of I want to learn how to fly a helicopter, that firmware update would be very bad if learning to fly a helicopter accidentally erased knowing how to walk, right? So you want to protect what you already know while acquiring new behavior somehow. Like it won't be perfect, But I mean, that's how humans learn. It's not like when we learn a new behavior, suddenly it unpredictably overwrites old behaviors we have learned.
So then basically we have to define what a behavior is, right? It's like rotating a motor, a behavior is just an affordance, right? So they're like they are two different things. So moving around, moving left and right and backward and so that is, I would say, like a behavior, but just rotating the motor is like kind of an affordance. So that separation we need to specify, and then maybe it's possible to do something. So basically you are uploading the behaviors based on the affordances the robot has.
So, by the way, in the chat, Christopher mentioned simulations, and there is something here, for the Kalman filter, basically tuning, I guess. Okay. I think simulation may not be fast enough. Okay. I guess it depends on the simulator and so on. But genomic simulators may not be fast enough. However, we do have a tumbler simulation in Webot. Okay. And what may be possible, what is possible, okay, is that your code for the ESP32 can be wrapped to be used in the simulator to do a rough training or rough tuning of the parameters for the Kalman filter, and after use OTA to try that on hardware. Perhaps that can be interesting, because otherwise you just using OTA is going, and LLM somewhere, huh? Okay, is going to take forever, I guess. So perhaps the LLM working on the source code and using the simulator to test, okay, until some threshold, okay? And at some point, the threshold is passed, and it can try on the with the OTA. Maybe
Well,
something very
I think the simulator for tuning the PID and Kalman only works if you have the inertial moments similar to what you have on the real robot, right? Otherwise, like how are
Yeah,
you
and
tuning?
so that's supported in Webot. Okay, there is a physics engine as well. And so in the model we have now, I put the weight of the different parts. Okay, not all of them. Okay, but I put the weight of different parts, like the motors, and I think the PCB, a few like that. Okay, because I was trying to simulate the IMU. It's simulated, huh? Okay, but it's not. I couldn't confirm whether it was working correctly. Okay, but we both supports IMU and inertia and stuff like that. It might be interesting
But
to
but
for a
how
rough.
is how is it measured of like the real robots, or do people even measure it, like the moments of physical stuff?
Oh,
Yeah, I mean, that's straightforward to calculate. If you have the weights and the geometry, you can get the basic parameters with fairly high accuracy. But if it's low accuracy and you kind of want to give it an approximate starting point and then use simulation to tune the parameters until you get it right, and then try to put that on the physical robot and see if that works, and then maybe use a camera to further tune in real time, I think that's going to be quite hard. Yeah, you have to get very close to the true parameters in order to do local search in parameter space. Otherwise, you'll be like, I don't know, brute forcing and like breaking the robot too much while trying to discover the correct parameters.
So what I was trying to build, one of the tracks I was trying is basically I asked the OpenSCAD model, right? So basically, like you could send the IMU data via WebSocket to a browser, and then the first thing I wanted to do was visualize the robot in the browser with the IMU orientation. That's why I was asking the OpenSCAD model. So basically, there are projects in which you can send the IMU data, and then you basically see some orientation in the computer or the browser or whatever. So basically, once you have like the IMU data and you can send it via WebSocket, you can see the IMU orientation in real time. So that's what I was trying to build in one of the tracks. It's not there yet, but yeah.
You also have JavaScript libraries to show an STL in 3D directly in the browser. I get this library is often used on these online libraries for 3D printing parts. You look at the part and you can visualize it. It's really, those cool dragons and so on that you can show. The library is pretty common apparently.
Yeah, we are 1 minute past. I don't know, like if you want to discuss the firmware update for the old. I didn't understand, Eric. What was the problem with your?
But the problem is to take the original Tumblr
Okay.
and to upload its original code to its original hardware. That's all. So it's to start from the start and after to do modifications.
So it's not working. What does it like? What is it doing? It's doing nothing.
Nothing. And so what I'm doing now is an incremental build in the sense that I deactivate most of it and I activate things and to try to find the point by dichotomy, but it's pretty quick. Okay, they have some C++ code that is a bit that is a bunch of code.
I think they have like a folder of, and then they have like 7 or 8 lessons in which they step by step build the entire robot firmware.
So I look at that, but first it doesn't look like the whole robot,
Okay.
and also you pick any folder, none of them builds. Just because
Okay. Because yeah, I never tried to build that entire thing, and then the original firmware that comes, I've never modified it. So what I've done is like given that folder to Cloud, and then asked, okay, this is the ESP32 endpoints I have. Use that balancer or Tumblr code to give me a ESP32 code. So that is what I've done.
I got that. And what I was asking is, has anyone managed to reinstall the Tumblr from scratch? Okay, with the
I can
original
try
hardware.
that. Yeah, I have a second Tumblr. I will try that. I haven't tried it because like I've always just tuned the Kalman filter in PID. I never truly understood what it actually does. So I just tuned by various
Anyway,
parameters.
I made some progress, but it's not back to its how to say its factory settings. Okay. So
Yeah,
maybe
and,
next week we. Oh, sorry, please.
I was saying I have a similar problem, so maybe sometime in the next few weeks we can run a session trying to troubleshoot both. But it can't be anytime soon for me, though we can maybe do yours, Eric. I'll be moving house in the next few weeks, so after I settle down, maybe then we can work on mine as well.
Okay. So are you available next week, Venkatesh? Because we'd like to discuss the community's last machine.
Available. I'll be available to join the calls and stuff, but I'll be packing up my stuff and not unpacking for like 4 or 5 weeks. So I won't be able to like do much with my hardware. But I have the same problem, is what I'm saying. So we should have a couple of sessions to troubleshoot, because the little bit I did, I think we did this together. Like I think almost 2 years ago, we flashed my Tumblr with the original code again. To make one very small change. We added a little buzzer, if you remember, based on the ultrasonic sensor. So we have done this in the past and it worked. But right after we made that change, my old Tumblr, the self-balancing, kind of stopped working properly. It kind of like flopped around a little bit. I never bothered to fix it. And then the new Tumblr that I got, when I turn it on, it doesn't even start balancing. The red LED turns on, which I think I looked up. It said something like, yeah, either the sensor might be dirty or it's the light is too little or something like that. I don't know. But I haven't yet been able to figure out why it's not even like doing the basic factory settings balancing. And so I have to basically troubleshoot both the boards. The old Tumblr is now running the ESP32, but I have the board from it. So I've tried both boards on the new Tumblr, so the factory boards, and neither of them works one way or the other.
Venkatesh, can I escalate what you're describing? How can we have an automated robotic troubleshooting system? In other words, we have a robot, and now the LLM, so to speak, has to figure out what's wrong and maybe also, propose things to do, send online patches and so on. So instead of
Yeah.
us debugging it, let's figure out how to have the AI debug it. We'll act as channels, filling in what we didn't code yet. And then,
Yeah, I think this is what doing. So like you would take the normal human troubleshooting tree of like, what's broken is the motor working, is the sensor working. So normal human troubleshooting tree, but try and have the LLM both figure it out and try it iteratively as deep as it goes and actually fix it. And I think you can't fully automate the loop yet, but maybe Cloud Code, if once you give it the basic repo, it can keep trying like iterations to keep flashing, and it'll say, now try this, did it work? And then we give it feedback on whether or not it works.
yeah,
I think that should be possible based on what Anurag showed us.
Yeah, this I am actually already doing in many of
Oh,
the
okay.
projects. So it's not.
Yeah, the problem ceases to become how to write firmware or how to fix bugs, but it's how to wire up a Claude code or whatever you're using with the right feedback loops to allow it to do the work for you, which
build
is
loops.
not always easy, but it's a different problem.
And also, Red, if you're back, maybe you can give us an update on whatever you've been up to. You seem to know a lot about this too.
Pretty much all of my creative powers have been dedicated to AI stuff, so that's why I haven't touched anything hardware in months and months.
All right. See you guys next week
Okay,
then.
we are almost 10 minutes. Okay, see you next week. And if you want to, if Chris, you are planning to join regularly, we could change the time, but let's discuss that in the main channel. So see you. Bye.
Okay.
Bye.